Good afternoon, viewers. Welcome back to Easy Mathematics. We thank God today is another day. As we said last week, today we are coming to look at position vectors, the last topic in vectors. Now, with position vectors, let's take a point as A to be x, y. So let's take point A on a graph as x, y. Now if I want to plot this on my graph, let's assume that the x and y are positive figures. So on the axis, we have the L shape. This is the origin, and let's say we have point A here, which is the x, y. Now with this, we'll notice that any point we plot on the graph is referred from the origin. So with this, we can say this is from the origin. So this is point A, and we are from the origin to the point. So if we want to write this as a vector, it means the point is referred from the origin. So the point A, in terms of vectors, since it is referred from the origin, it gives us the vector OA, which is equivalent to small letter a. So now that this OA is a vector, then we can write this point as a vector in a vertical column by saying that the vector OA is the position vector of point A. So when we say position vectors, they are simply the vectors or the vectors of a point, or when we transfer a point into vectors, that vector is a position vector. So if I have point A as xy, and I'm to find its position vector, since always on a graph or a point, every point is referred from the origin, which is O. So from O to the point gives you the vector OA, which means we are from O, which is the origin, going to A. So this is the same as the small letter a, which is equal to x, y. So this vector is the position vector. So vector OA or vector A is a position vector. And that is how we write a vector for a single point. Now let's look at the example here. It says write the position vectors of the following. So we have point. This is a point. Remember that when we started, we said vectors are written vertically, but points are horizontally written. So this is point, not a vector. So if I want to write this point as a vector, every point is referred from the origin. So to write this in vectors, since it is referred from the origin, I will say vector OP, which means I'm from the origin going to the point. And this is equivalent to small letter p, which is equal to, then you write this in a vertically form or format as 3, 2. So the position vector for this point is vector OP, which is 3, 2, vertically written. And that is how we write a position vector. So this is the position vector, and it is represented by from the origin to the point. Then with the second one, we have point Q as 3, -1. The same thing, point Q, 3, -1. To write its position vector, every point is referred from the origin. So this is OQ, which is a vector. So OQ is equivalent to letter Q, small letter Q, which is equal to the vector. We just write this in a vertical way, 3, -1. And we say this is the position vector of the given point. So with a single point, you just locate the origin, then your arrow with the point, then you write the vertical of the point. So the C, we have OC, vector OC, which is equal to small letter c, also equivalent to -6, 8. And this is how we calculate for the position vector of a point. Now let's look at the next one. It says expressing two given points as a vector. Here they've given you 2 points. So let's assume, or let's say, we have point A as x1, y1, and we have point B as x2, y2. So we have 2 points, and they are saying that we should express these 2 points as a vector. They are not vectors, but we should express both of the points as a vector. Now, if I want to plot this point on my graph, let's assume that they are all positive values. Let's say A is here, so I have point A here, and B is somewhere here. I have point B here. When we're looking at a single point, I told you that every point is referred from the origin. So this point is from the origin. And this point is also from the origin. So we can join this together to form a triangle. So this is the origin O, because anytime we draw a Cartesian plane on the x and y axis, where they meet, we name them O, which is the origin. So the origin is a referred point of every point. So every point is referred from the origin. Good. So here we are from O going to A. So we indicate this with an arrow, meaning we are from we are from O going to A. Also, every point is referred from the origin. Also, we are from O going to what? A. Going to B, sorry. So we can see that this, we have 2 points on the graph, and they want us to express these 2 points on the graph. So this vector O, this origin O, is moving to the point A. This vector origin O is also moving to the point B. So here, this gives us the point in terms of vectors as vector AB. So if we are to express 2 given points as a vector, we say the point which is AB is calculated as the origin of the second point. The second point is B, and the first point is A. So the origin of the second point, which is B, minus the origin of the first point. So we say the second point is OB, vector OB, minus the first point, vector OA. And you will notice that this OB and OA is equal to what we started here, where we change a point to a vector. So if I am to transfer or express these 2 points into a vector, then it means the given vector that I'm going to express the point into, I'm going to subtract the first point from the second point. So I am going to subtract the vector OA from OB. So OB is the second point, and OA is the first point. And the OB means we are from the origin moving to the point B. And the OA means we are from the origin moving to the point A. So from here, you look at it carefully and ask yourself, what is the point for B? The point for B is x2, y2. So you just put them there. Since this is OB, it means it is a vector. Since this is OB, it means it is a vector. So we were able to write this as 3, 2. So this being a vector, we can say B minus A. So the point x2, y2 can now be written as x2, y2 in a vector form minus A, which is the vector OA, this as x1, y1. And this will be like subtraction of vectors, which has already been treated in our previous video. So with the expression of 2 given points as a vector, look at the given point and look at the given vector. Subtract the first point from the second point. So you will notice that OA is just like me writing it in a letter A and writing the point in a vertical way. Then OB also is the same thing. Then you do your subtraction of the values. Then you go. And we say you've calculated for the position vector and expressing two vectors, 2 points as a vector. So if I give you vector CD and it's a point, it simply means you are going to subtract the first point from the second point. So vector OD minus vector OC. Always we subtract the first from the second point. So if I also give you PQ, vector PQ, you are going to subtract the P from the Q. So you are going to say OQ minus OP in that order. If I give you XY, it means OY minus OX. Then we say you've expressed the two given points in vectors. So let's take the first question. If the point A, this is point, not a vector. If the point A is 4, 8, and the point B is negative 1, 5, find vector AB. So these are points, and we have to express it in a vector. So to solve for this, I am going to say the vector AB is equal to, we are going to subtract the first point from the second point. What is the first point? A. What is the second point? B. So we are going to say OB, vector OB minus OA. That's vector OA. How did I get OB? OB, since the point B is always referred from the origin, it means we are from O going to B, which has been explained here. And why is it OA? It's because we are from the origin O going to A. And always remember that every point is referred from the origin O. So to do this, I have the point OB. I have the point B as this. And I have the point A as this. So this is equivalent to B minus A. So I'm just going to change the OB, which is the B point, into vectors. And that will give me negative 1, 5 minus OA. OA is now a vector, but I have the point as A. So to change the A into vector as its position vector, OA, I'm just going to write this in a vertical way as 4, 8. So you will notice that the OA is a position vector for the point A. And the OB is a position vector for the point B. So negative 1, 5 is the point for B. But in terms of position vectors, it is vector OB. And you have here negative 1, 5, which is a vector. Then this is A, OA. And it is also a point A. But this is the position vector for point A. I hope you are getting it. So this is the point, but this OA is the position vector. Then now I have negative 1, 5 minus 4, 8. So negative 1 minus 4. Negative 1 minus 4. You owe. And this is going to give you negative 5. Then 5 minus 8. 5 minus 8 will give you negative 3. So this is negative 3. So therefore, the vector AB is equal to negative 5, negative 3. And this is the position vector. So this AB are the points, the point A and B is what we've expressed as a vector AB. So we've expressed the 2 points as a vector. So vector AB is the point A and B, which has been expressed as a vector to get negative 5, negative 3. Let's look at the second example. If point P, negative 6, 8, and Q, negative 10, 6. If point P is this, and point Q is this, find the vector PQ. So P is a point, Q is also a point. But we are expressing these two vectors, these 2 points, as a vector. And we know that to express a point as a vector, or to find the position vector of a point, every point is referred from the origin. So you can calculate for OP, which is the same as small letter p, and that of OQ, which is the same as small letter what? Q. So I'm to calculate for I, vector PQ. Now this vector PQ is the same as the first point vector minus the second point vector. So we say OQ minus OP. Why is it OQ? Because the point Q is referred from an origin O. And this O also, which is the point P, is also referred from an origin P. So if I want to write this Q as a vector, then how to refer it from its origin? So the vector OQ is now the position vector for this point Q. So OQ, which is now the position vector, can be written as negative 10, 6. Then minus OP. Now the point here is P, which is also referred from the origin O. So since it is referred from the origin O, it gives us OP as the position vector. So I can now write this point negative 6, 8 as a vector as negative 6, 8. This way. And now this becomes subtraction of vectors. So I have negative 10 minus negative 6. When negative meets or multiplies each other, it produces what? Positive. So this becomes negative 10 plus 6, which is equivalent to negative 4. Then you have 6 minus 8. 6 taking away 8 is not possible. So it gives you negative 2. So therefore, vector PQ is equal to negative 4, negative 2. And this means we have expressed these two vectors, these 2 points, as a vector PQ. So always the second point minus the first point. The last but one on this, if the point X is negative 1, 3, and the point Y is 2, 5, find XY. But if you look at this carefully, we have II here. And II is says you should find the length or the magnitude. Okay, also I will throw that as a challenge for you to solve. Find the magnitude. This is now the PQ. So find the magnitude of PQ and send your answer to a WhatsApp number which will be given after the class. So we have already talked about magnitude. This means magnitude or the length. So find the length PQ. We've calculated PQ. So calculate for the length. Then you produce your answer on the WhatsApp number that will be given after the class. Thank you. So we have here, if the point is this, point X is this, and point Y is this, find the vector XY. So I've been asked to find the vector XY. Now I know that to find the vector XY, I am going to subtract the first point from the second point. In other words, the second point minus the first. So what is the second point here? Y. So in terms of vectors, because the point Y is referred from an origin O, I'm going to say vector OY, which is a position vector of the point Y. Then minus the first point, OX. OX because the point X is referred from an origin O. So this OY is the position vector for this point, and this OX is the position vector for this point. So you just do your substitution, or you replace them by their right vectors. So now this is a vector. I can write the point 2y as 2, 5. Minus, this is OX. Be careful you don't give the points for X for Y, because you said OY. So you go for the Y component. Then this is OX. Now this is a vector, or this is a position vector. I can write this as position vector -3, -1, 3. Then this is 2 minus -1, which means 2 plus 1. And this is equivalent to 3. Then I have 5 minus 2. No, sorry, 5 minus 3, which is 2. So therefore, vector xy is equal to 3, 2. And you have expressed the point x and y as a vector xy. You can be asked to calculate for yx, vector yx, which is the inverse of this. Also, we've talked about it by just negating this vector or multiplying by -1 to get -3, -2, and that is yx. You can also be asked to calculate the magnitude. If your answer is correct, you can get it. And let's look at the last. Good. So let's look at the last question for the day. A triangle ABC has vertices A as this, B as this, and C as this. So these are the vertices of the triangle. The question is saying that find the length of the sides AB and AC. Show that the triangle is an isosceles. So a triangle ABC has these vertices. So this is the vertex for A, for B, and for C. So let's first draw the triangle. Let's take this as our triangle. And it is having vertices as A, B, and C. So what is the vertex for A from the question? It has -2, -4, and B is 10, 1, and C is 3, 8. Now the question is asking you to find the length of the side AB and AC. Now how can you find the sides whilst you have been given vertices? So it means the length that we are going to find, which is the magnitude of AB, it means express the given point A and B to get vector AB. So from the question here, we have AB saying that we are from A going to B, which means we are from B, we definitely come back to what? C. And AC becomes the resultant vector. So what do? AB, or the vector AB, must be written using the point of A and B, which is expressing 2 points as a vector. So the vector AB is equal to the second point minus the first point. Second point is B. But since the point is referred from the origin, we will say OB, or vector OB minus vector OA. So this vector OB is the position vector for the point B. So we just write 10, 1. Minus OA, which is the position vector of the point -2, -4. So this is -2, -4. Then we solve using the subtraction. So 10 minus -2 will give us 12, because this will be positive. Then 1 minus -4 will give us 5. So the vector AB is equal to 12, 5. So this is the vector AB. But the question said, find the length of AB. So now that we know AB, we are going to find the length of AB. And how do we calculate for length? So the length AB can be calculated as the square root of the x component squared plus the y component squared. What is the x component? 12. The 5 is the y component. So square root of 12 squared plus 5 squared. 12 squared is 144 plus 5 squared is 25. This plus this will give us the square root of 169, which is equivalent to 13 units as the length of AB. Good. Then we also find out of AC. So AC is now a vector, but the A that they're giving us is a point, and the C is also a point. So the second minus the first. The second point is C, but this is the position vector, which is going to be written as 3, 8. Minus A. This is the position vector. This is the point, which is going to be written as -2, -4. Then we do our subtraction. So 3 minus -2. When the 2 meet, this gives positive. So this becomes 3 plus 2, 5. 8 minus -4, 12. So AC, vector AC, is equal to 5, 12. Since we have to find the length, also we are going to find the length of vector AC, which is 5 squared plus 12 squared. So the square root 5 squared is 25 plus 144. This gives you 169, which is 13 units. When you look at the length of AC and that of AB, they are the same. We have AC's length. The length of AC as 13 units, and the length of AB as 13 units, and AC also as 13 units, which means the triangle ABC is an isosceles. And when we say isosceles, what is an isosceles triangle? An isosceles triangle is a triangle having two sides to be equal. So we draw triangle ABC again, this way, indicate the vertices A, B, and C. And we say A, C are equal, which means this length AC and this length AB are equal. So therefore, triangle ABC is an isosceles triangle. But if in case we solve and we have different answers as the magnitude or as the length, then it means that triangle is not. But here in this case, it is an isosceles triangle. Thank you for staying tuned. This is the WhatsApp number we can send the solution to. Let's try our hands by finding the magnitude or the length of PQ. Send your WhatsApp number, send your answer to this WhatsApp number, and we will be glad to know that you are also learning from our platform. Thank you for staying tuned. See you God willing next week as we talk about construction. Bye-bye.